Blockchain is a revolutionary technology that has the potential to change the way we conduct transactions and manage data. At its core, blockchain is a decentralized, digital ledger that records transactions across a network of computers. This technology allows for the creation of tamper-proof records that can be accessed and verified by anyone on the network. Blockchain technology was first introduced in 2008 with the launch of the cryptocurrency, Bitcoin. The importance of blockchain technology cannot be overstated. It has the potential to increase transparency and security, reduce costs, and improve efficiency in many industries. It also has the potential to empower individuals and organizations by giving them more control over their data and assets. How blockchain works. Blockchain technology is based on a distributed ledger system, which means that the ledger is spread across a network of computers, rather than being stored in a central location. Each computer on the network, known as a node, has a copy of the ledger, and all transactions are recorded on each copy. This ensures that the ledger is tamper-proof and can be accessed and verified by anyone on the network. In order for a new transaction to be added to the ledger, it must be verified by the nodes on the network. This is done through a consensus algorithm, which is a set of rules that nodes use to agree on the validity of a transaction. The most common consensus algorithms used in blockchain are proof of work, POW, and proof of stake, POS. In POW, nodes compete to solve a complex mathematical problem, and the first node to solve it is allowed to add the new transaction to the ledger. In POS, nodes are chosen to validate transactions based on the number of tokens they hold, known as their stake. Smart contracts. Smart contracts are self-executing contracts with the terms of the agreement between buyer and seller being directly written into lines of code. They are programmed to automatically execute when certain conditions are met. Smart contracts allow for the creation of trustless, decentralized systems, where transactions can be executed without the need for intermediaries. This makes them a powerful tool for automating processes and reducing costs in various industries. Blockchain applications. Cryptocurrency is one of the most well-known and widely used applications of blockchain technology. Bitcoin, the first and most popular cryptocurrency, was created in 2008 as a decentralized, digital alternative to traditional fiat currencies. Since then, thousands of other cryptocurrencies have been created, such as Ethereum, Litecoin, and Ripple. Cryptocurrencies allow for fast and secure peer-to-peer transactions without the need for intermediaries such as banks. Supply chain management. Blockchain technology can be used to improve supply chain management by providing transparency and traceability. By recording each step of the supply chain process on the blockchain, it is possible to track products from the manufacturer to the consumer, ensuring that products are authentic and have not been tampered with. Healthcare. Blockchain technology can be used to improve the healthcare industry by providing secure and transparent record-keeping. Patients' medical records can be recorded on the blockchain, allowing for secure sharing of information between healthcare providers. Banking and finance. Blockchain technology has the potential to revolutionize the banking and finance industry by reducing costs and increasing efficiency. Blockchain-based systems can be used for faster and more secure transactions, as well as for the creation of decentralized financial systems. Internet of Things, IoT. Blockchain technology can be used in conjunction with the Internet of Things, IoT, to create secure and decentralized networks. This can include the use of blockchain-based systems to secure communication between IoT devices, as well as the use of blockchain-based systems to track and manage the data generated by IoT devices. Some additional applications of blockchain technology that can be included: government and public services, identity management, real estate, energy, art and collectibles, gaming and virtual reality. These are just some examples of how blockchain technology can be applied in different industries. There are many more possibilities that are being explored by researchers and entrepreneurs. As blockchain technology continues to evolve, the number of applications and use cases will likely continue to grow. Blockchain security and privacy. Blockchain technology is inherently secure, but there are still potential vulnerabilities that need to be addressed. One of the main security measures used in blockchain is encryption, which is used to protect the confidentiality of data stored on the blockchain. Additionally, blockchain networks are decentralized, which means that there is no single point of failure, making them more resistant to attack. Privacy concerns. One of the main concerns with blockchain technology is privacy. Because all transactions are recorded on the blockchain, it is possible for anyone to see the details of a transaction. This can be a concern for individuals who want to keep their financial information private. Current challenges and future developments. Despite its many benefits, blockchain technology still faces several challenges that need to be addressed. One of the main challenges is scalability, as the current infrastructure of many blockchain networks is not able to handle large numbers of transactions. The use of off-chain transactions and sidechains is being explored as a way to increase the scalability of blockchain networks. Other security measures include multi-signature and smart contract security, both of which are used to ensure that only authorized parties are able to access or manipulate the data stored on the blockchain. Multi-signature requires multiple parties to sign off on a transaction before it can be processed, while smart contract security ensures that the terms of a contract are followed and that the contract is executed as programmed. Blockchain security is being improved with the implementation of formal verification, which is a mathematical method for verifying the correctness of smart contracts and blockchain protocols. This technique is highly effective in identifying security vulnerabilities and bugs in smart contracts, which is important in financial and other sensitive industries. Despite the security measures implemented in blockchain, the technology is still relatively new, and ongoing research is needed to address the challenges that arise. With the increasing adoption and experimentation of blockchain technology, it is expected that security and privacy concerns will be mitigated over time. Conclusion. Blockchain technology is not only about the technology itself, but also about the people, communities, and organizations that are working to develop and implement it. By understanding the potential impact of blockchain technology and staying informed about the latest developments, you will be better equipped to contribute to the growth and evolution of this powerful technology. Thank you for watching this video about blockchain. Please like, follow, and comment to help my page grow. Check out my website for all of my content and to learn more about crypto. www.haddiesshack.org